Thank you very much, and good afternoon, everybody, and welcome to our session this afternoon on effective security with Zero Trust and Network Relay. My name is Alexander Dove, and I am a senior sales engineer here at Jamf, specializing in our security products. And I'm joined this afternoon by my esteemed colleague, Iulia, who will introduce herself.
Hi, everyone. I'm Iulia Arghir. I'm a senior product manager, and I work with the teams that have developed a lot of the security features that you guys have seen today.
Awesome. Perfect. Well, without further ado, let's get stuck in. Now, we're going to be covering three key topics as a part of this presentation today. And we're going to break this down into some key components about the topic. Firstly, why is Zero Trust a necessity today? We're looking at the changing way of working and the risks of current times and why they create a necessity for a Zero Trust approach across organizations. And then we're going to move on and talk about the advantages that you gain from a Zero Trust strategy. And then finally, we'll start to move into the Jamf Zero Trust framework. We'll take a look at how Jamf tackles these kinds of challenges that are around there today that create a Zero Trust necessity and how we can deliver on those advantages. So without further ado, the Zero Trust necessity. Now, to kick us off here, the most important thing about setting this scene is to talk about this key fact. Users are increasingly remote today, and they're remote on mobile devices and any other types of devices. They're doing their work on all different types of platforms. And as a relevant statistic, remote working has more than quadrupled in the last decade. Data is moving outside of the traditional corporate perimeter. And as a result of this, 85% of workers no longer sit behind a desk in the way that they once did. And that means that business processes, tasks that they would normally have done behind a desk, are now going mobile across the board. And as a result of this means that our apps are now everywhere. That's not just on-premise, but in the cloud as well. And again, as a supporting statistic of this, that also means that 90% of those workloads and those tasks are now also in the cloud. And so support for a hybrid working environment is becoming more important than it ever has been before. And it's as a result of these factors that have paved the way for Zero Trust as a strategy or as a concept. To highlight this, 84% of organizations are now actively exploring a Zero Trust strategy. Now, with these changing trends considered, traditional perimeter protection is no longer adequate, hence that drive towards Zero Trust. And this trend is further exacerbated by some other additional challenges, things that we see today. So firstly, cyber threats like ransomware, phishing, insider attacks, they are all growing much, much more advanced all the time. And so, adoption of security and new technologies must stay ahead of these evolving threats. And then secondly, we have things like political instability. Wars, tariffs, and other third-party risks can massively disrupt and compromise supply chains and so on. So it's important to enforce strict access controls for these types of tasks. And thirdly, organizations now face incredibly tight budgets and rising compliance demands. Implementing cost-effective security is absolutely vital in order to meet regulatory compliance requirements that we see today, like NIS2. And lastly, AI tools. The rapid rise and growth of AI and automation tools is extremely fun and they're very efficient, but they bring with them new risks, like automated attacks or those tools themselves actively being misused. So it is important that even these tools follow very strict identity and access rules to keep things secure and compliant. So it's the culmination of all of these things that drive or pave that requirement for a Zero Trust approach amongst organizations today. But before we look at how we can solve these challenges, or how Zero Trust solves these challenges, let's take a quick look at why traditional VPN, traditional perimeter protection tools, struggle to do so. Now, broad strokes purposes, when we think VPN in the traditional sense, this is the sort of thing we imagine. We imagine an endpoint with an encrypted tunnel into a network. It's about the size of it. Now, on the surface, this looks incredibly simple and straightforward, but in reality, it isn't at all. We only have to scratch a little bit further to see just how much it really isn't that simple. So first and foremost, big problem number one, it is complex to manage. It means there is hardware to set up. That might be firewalls, it might be concentrators. Configuring these is complex. And then on top of that, you've got things like certificates to manage as well. And all of this comes at a great cost, not just the hardware itself, but running it, something that can often require entire teams to do. And even after all this, establishing that VPN still requires a lengthy 5-step process. Firstly, we've got certificate validation, steps 1 and 2. Then we've got your token exchange, typically, steps 3 and 4. And only then can we get to step 5 and establish that tunnel between the device and the network. Which brings me neatly onto big problem number 2. It is substandard to manage. Now, due to this connection process, connection speeds are often very, very slow. But the pain doesn't stop here. Now, though you can now access your on-premise applications, what about your cloud or your SaaS applications? To get to those, we then need to break back out of this corporate perimeter to get to those, which is another whole step entirely. That brings us on to step 6, that breakout to get to our cloud applications. And when it comes to mobile devices, as I said earlier, that broad variety of different devices our users are now working on, the impact of all this is multiplied even further. Slow connection speeds don't meet the expectations that we've come to expect from our fast, agile iPhones and our mobile devices. And that lengthy connection process requires an excessive amount of processing power, leading to excessive battery consumption, and even things like changing networks between mobile data and a Wi-Fi network requires that whole process to go all over again. So ultimately, the user experience is really, really harmed as a result of this. Now, you could try and improve these connection speeds by going directly to those applications. But in order to do this, you've then got yet more configuration to complete, such as split tunneling and etc. And this removes the benefit of VPN-level encryption, which potentially exposes these devices to man-in-the-middle or adversary-in-the-middle type threats. Which brings me perfectly on to big problem number 3, which is the fact that these are insecure by design. Firstly, lateral movement is permitted. Users can access all of the applications within that perimeter, even though they're not supposed to. And what then happens if, or rather when, an endpoint gets compromised? Well, firstly, the attacker gains access to the entire perimeter. And then they can target all of the apps within that perimeter. And then equally, they can target the SaaS applications off the back of that being a trusted perimeter. So with traditional VPN, there is no proactive protection. It is the opposite. Defense is reactive. It is after the fact, when it's already too late. Now lastly, connections are established on assumed trust. Connections are allowed into this environment simply because the configuration on the device is correct or right. When we lay it out in full, it's clear to see this is really not as simple as it looked at first glance. It really isn't. It's actually very, very complex indeed. And equally, it's outdated and it's flawed. And it's these flaws, again, that have paved the way for that zero trust approach. Now, before we move into a little bit more about that zero trust approach, we're going to set the scene a little bit further just by focusing on that final and most critical security flaw. How traditional perimeter-based VPNs like this assume trust. With this approach, all it really takes to get connected, again, is that right VPN configuration. As long as you've got the right configuration, that's all you need. What or who is using said configuration is never verified. And because we're not running these verification checks, we assume that the devices using the VPN are known to us or trusted. And we assume that the people using those devices are authorized. With traditional VPN, by the time we discover an unauthorized device or an unauthorized person attempting to access data, it is already too late. But with the zero trust approach, on the other hand, it is the polar opposite, which brings me on to the ZTNA advantage, right? This is the clear advantage in a zero trust approach. Zero trust is the opposite to that mantra. It works on a single concept. It works on the concept of never trust, always verify. Now, with a zero trust approach, before any connections are permitted, we verify that the devices are known or trusted, and we do that by checking their management state, for example. And we also verify that the users are authorized against maybe an identity platform or similar. Now, with zero trust, proactive security is priority number one. And thus, unauthorized access requests are never even allowed to start with. And that's the key difference. Now, better still, the zero trust approach simplifies remote access significantly versus that former model. When we lay this out in full, just as we have done with traditional perimeter-based VPNs, it's clear to see just how much simpler things become. Now, as we've just been over, zero trust is secure by design. This is the big point number one. And equally, so is Jamf Connect Zero Trust. Now, whenever there's an attempt to access a business application, we first verify that the device is known and trusted and that the user is in fact authorized. Now, there are multiple ways in which we can do this. We can check the device's management state in MDM. We could check that the user is authorized in the identity platform. But it's only once this crucial step is completed that things can move forward. Next, we establish an encrypted VPN microtunnel for the requested app into the Jamf Security Cloud ingress network. Now, Jamf Security Cloud acts as a software-defined perimeter, or an SDP. It becomes the gatekeeper for all access requests. And as a result, it delivers real-time contextual risk evaluation for all access requests. Now, provided these contextual policies are satisfied, then traffic is routed to its destination app via the Jamf Security Cloud egress network. It leaves it on that side. But when a request exceeds the defined risk level, for example, maybe where the device is running a vulnerable operating system, it gets blocked. These policies are continuously enforced. If the risk level changes midway through a connection, it gets severed, keeping the data safe at all times. Now, as a further security advantage, Jamf Connect Zero Trust eliminates that risk of lateral movement that we see with traditional perimeter VPNs. Now, when a user tries to access another different business app, an entirely new micro-tunnel gets established, keeping things entirely separate. Now, this flexible micro-tunnel design goes a long way in delivering a truly seamless user experience. Which brings me on to the next point. With Jamf Connect ZTNA, we can create multiple different egress routes out of Jamf's cloud. Cloud apps can be accessed via both shared or dedicated egress routes. And on-premise applications can be accessed via private IPsec tunnels. Now, as a result, users can access all of their apps simultaneously, regardless of where they're located, without any kind of interruption. And thanks to the use of modern VPN protocols and authentication techniques, users can access their apps at near native speeds, the way they've come to expect that to work on their mobile devices. Tunnels are established immediately without the need for lengthy certificate exchanges, which leads to up to sort of 4 or 5 times the throughput of the speed, a further tick in the box for mobility. And these speeds are even further improved due to the fact that only business app traffic is routed through Zero Trust. Everything non-business related takes the standard ISP route. Everything non-business related is then protected and kept private for the user's sake. And equally, all of this performs correctly alongside the threat defense capabilities of Jamf Protect, offering real-time threat defense and content control in line. So that's about the size of it. Getting connected with a zero trust approach really is that simple. And accordingly, big plus number 3, it becomes much simpler to manage over time. Jamf Connect Zero Trust integrates natively with both MDM and identity provider solutions for secure verification. And that means that admins don't have to maintain a separate list of users or devices. There's no more time wasted on duplication of tasks that they have already done. The integrations take care of everything continuously and automatically. And as all of this is cloud native, there's no hardware to manage or certificates to keep track of. A big problem with those traditional perimeter-based VPN solutions. And lastly, the service is very, very easily configured through the Jamf Security Cloud portal. Adding a new business application is as simple as creating a new access policy, and so scaling is fast and efficient. Now, as I'm sure you'll agree, when we bring the two up side by side here, it becomes immediately visible just how much simpler the Zero Trust is compared to the traditional perimeter VPN approach. But even now, we are only just scratching the surface of the advantages here. To help us get to grips with that just a little bit deeper, we're going to talk about its advantages in terms of 5 key categories: user experience, compatibility, security, productivity, and cost reduction. So for that first category, user experience, as we've discussed, it's high speed, low latency, which gets people connected to their applications faster and improves that experience overall. And in turn, much lower battery and CPU consumption, which is what our users want from these modern mobile devices. They don't want to be interrupted, they don't want to be charging more, they want their device to operate correctly and well. And then it's privacy conscious. Their personal data is not routed through business channels. That protects it and keeps them reassured that their personal information is not being exposed. And lastly, it's the same consistent connectivity experience across all of their devices. Their mobile, their tablet, their Mac, doesn't make any difference. In terms of connectivity, support for both cloud and on-premise applications. It doesn't matter where those applications live, they are easily connected to. And that access is simultaneous. You can access all of these applications in all locations at the same time. And equally, it works alongside Jamf Protect for inline content control and threat defense capabilities. A surprising challenge with more traditional VPN solutions is the conflict between these types of solutions. They often will not work side by side. In terms of security, data is encrypted in transit, even for those cloud or those SaaS applications, which prevents those risks of man in the middle and adversary in the middle type threats. It prevents lateral movement. It prevents our users from getting to applications they shouldn't inherently be able to access based on their role or permission set. And it enforces risk-aware, context-based access. And this means faster task completion. Users can get their work done more quickly and more efficiently. And if they're able to access their applications on any device, wherever they are, they've got more opportunity to do these tasks more quickly. And rather than picking and choosing which applications we let them have access to based on their device contacts, we say, great, access everything that you would need to for your normal business role all the time, wherever you are, further increasing their productivity. And of course, if we're increasing productivity, then we are increasing an organization's return on investment in terms of their technology. Technology is expensive. We're paying so much money for this stuff, we need to make sure we're getting the best possible return out of it. And then lastly, in terms of cost reduction, there's no hardware to maintain. We're removing that hassle, which means much, much lower IT operational costs, not just in terms of the hardware initially, but in terms of maintaining it and the teams required to maintain it. It's infinitely and immediately scalable. We can do these things very, very quickly. New policies are simple and quick to set up, which saves yet more IT overhead and time. And because it's that much lower risk in terms of the security advantages, that minimizes our risk of breaches, thus reducing our risk exposure to cost. Now, you might be thinking, everything I've talked about here so far has been very much the marketing pitch for Jamf Connect ZTNA, but I promise you it is not. And I'm going to prove that with the help of some more statistics. Now, with respect to user experience, 60% of enterprises are now transitioning from traditional VPNs to Zero Trust in order to enhance user experience and simplify management. Just while that one sinks in, they're actively choosing to do it primarily because of user experience and also to reduce their management overhead. And then on compatibility, 68% of IT decision makers believe that secure cloud transformation is not possible with legacy network VPN-type perimeter technologies, which indicates their strong preference for zero trust over traditional connectivity. And then security-wise, implementing zero trust can reduce lateral movement within networks by up to 90%, which is massive. That massively increases security posture. On productivity, organizations that are adopting a zero trust approach have experienced 50% faster onboarding, which enables access to mission-critical systems in half the time. And finally, on cost reduction. Implementing zero trust has, on average, led to savings of up to $306 million over an average period of 12 years for organizations. Now, whilst I let those stats sink in for just a minute, I'm going to reintroduce you to my esteemed colleague, Iulia, to take you through more of the technical engineering behind Jamf Connect Zero Trust. Iulia.
Thank you, Alex. All right, so for the next part of the presentation, I'm going to walk us through how Jamf's own solution for zero trust network access can help deliver those advantages that we talked about. To start, think of this as the 10,000-feet view. Jamf ZTNA is a fully managed, cloud-hosted solution delivered as part of the Jamf Security Cloud. There's no hardware to deploy, no software to spin up, and no infrastructure for you to maintain. It runs on a global architecture with 2 core data centers in US and in Ireland. This is the management plane. I think this is where the configuration, the settings, the data, this is where they're stored, and 13 edge data centers that are distributed around the globe. This is where the actual traffic comes in and out. Alex already mentioned the solution was built from the ground up on this software-defined perimeter model. And while it delivers very similar outcomes to traditional VPNs, it's actually a lot more secure, more streamlined, and it works entirely different. Real-time decisions are based on device identity and user identity. We create these application-specific tunnels instead of providing broad network access. And we leverage a lot of modern, cloud-forward, cloud-native networking technologies. Before we dive deeper, I want to introduce at this point this concept of connection brokering. It's very important. Essentially, Jamf acts as a connectivity broker where every single request issued by any of your devices that's targeting a business-critical application is going to be routed through the Jamf Cloud. So first, we handle the ingress flow. This is the traffic from the device that's tunneled into our cloud. And then once a connection is approved, based on criteria that you define, we egress that traffic. We send it out of our cloud to the right destination, whether that's a SaaS application or something privately hosted. So on the next step here, we're going to move into a more concrete view of the architecture. We're starting with the way the traffic is secured into the cloud. So there are 2 tunneling options. For mixed environments where you have Windows and Android devices in addition to your Apple devices, we provide a WireGuard-based tunnel, which is integrated with Jamf Trust. Users will launch the Jamf Trust and log in using their corporate credentials against the identity provider you configure, and only then the tunnel will be established. And then for Apple-only fleets, Network Relay is our newest tunneling method. It may be a better fit. This was recently released as a release candidate for mobile. It continues to be in beta for Mac, but we're making great strides to close the gap there and make it generally available. In this setup, network access is provisioned automatically based on device identity. Beyond the tunneling method, at the core of the architecture, we have the access policy engine. For each business application that you want to protect, you're going to define an access policy that will include all the host names associated with that application. You're going to define what are the devices that are authorized for access, as well as the conditions that need to be met by those devices in order for access to be provided. Also, as part of each of these policies, you define the egress gateway. This is how approved traffic leaves Jamf Cloud and reaches the actual destination. For public-facing applications, you have two options. You have the shared gateways, which are part of Jamf's shared infrastructure, or you have the dedicated gateways, which provide you with customer-specific IPs reserved for your organization alone. No matter which you choose between these two types of internet gateways, we recommend that you configure your identity provider or application settings so that you only allow traffic from these known egress IPs. This way, you can be sure that only trusted traffic reaches what otherwise is a publicly reachable service. For privately hosted applications, we support dedicated site-to-site IPsec tunnels that you configure between the Jamf Cloud and your environment. And very important, all these gateway types support high availability configurations, which can be optimized for redundancy, for load balancing the traffic, or for fastest path routing. Okay, over the next few slides, we're gonna walk step by step and see what happens when a user or a process on a device is trying to connect to an application that is protected by an access policy. In our first example, the application is a SaaS service. It's hosted at this hostname, app.acme.inc. And the policy that includes it defines the egress gateway as one of the internet gateways, with this being a public service. Also, in our example, the device uses a WireGuard setup. When the user signed in to Jamf Trust and the tunnel came up, a few things happened. A WireGuard interface came up with an IPv6 assigned to it. A set of IPv6 routes were negotiated for that network interface, and an IPv6 Jamf managed DNS server was applied, this way ensuring that all DNS resolution will stay within the Jamf Cloud. These are all Jamf reserved IPv6 ranges and addresses, so there's no risk of conflicts or any overlap with your environments. So let's walk through the flow. The user opens their browser and then types in the hostname of the application they want to connect to. The DNS request is going to be sent through the WireGuard tunnel and reaches the Jamf DNS server in the cloud. The DNS server then looks up the actual IP of the application. With this, in our example, being a public service, our Cloud's resolver is going to recurse against public resolvers. If this were a private application, that DNS lookup would be handled by forwarding to the customer's internal DNS infrastructure over an IPsec tunnel. This is pretty easy to configure, so let's move on. So with that real IPv4 retrieved, the next step, the access policy evaluation begins and checks first if the hostname is included in any of your configured applications. In other words, is this a protected business critical application? And if so, we check a few things. We check whether the device is authorized, so this is how we enforce least privilege. We check whether the device is managed. And we can also check for the device risk level to see if it's within the acceptable threshold defined for that policy. And if everything checks out, the ZTNA Cloud Fabric generates this ephemeral IPv6 address that is mapped to the real IPv4. And then what gets sent to back to the device is the ephemeral IPv6 address. So back on the device, a new socket is created to this ephemeral IPv6 address, and all application traffic is sent through the WireGuard tunnel into the Jamf Cloud, and then traffic flows in and through the cloud based on this mapping between the device ID, the IPv6 address, and the real IPv4 address. And packets are routed out of the cloud via the designated egress internet gateway for the targeted application. Okay. If the application was a privately hosted application, the flow stays nearly the same. So the DNS resolution, the ephemeral IP assignment, all works just like it did for the public applications. The only difference is at the egress side, where instead of using an internet gateway, the traffic is now routed through an IPsec tunnel. So this is how access to work applications, business application is handled. It's securely, it's policy-driven, and it's invisible to the user. And the key point here is that the device never learned of the real IP of the application, which goes a long way to help against reconnaissance or lateral movement type of attacks. Another important aspect to highlight while we're here is that access conditions are not checked just once, but they're continuously evaluated throughout the duration of an active session. So even after access was granted, if the device falls out of compliance at any point, for example, is removed from management, the connection is immediately terminated. All the routing components that supported that connectivity in the first place are torn down in real time. So this is how we enforce the zero trust principle of never trust, always verify. And lastly, for this section, we're going to look at how regular internet traffic is handled. Let's say a device tries to connect to Facebook. Even in this case, we have the WireGuard tunnel that's still active, and the flow starts the same way with the DNS lookup for facebook.com, which reaches the Jamf DNS server in the cloud, resolution of that host name, and then at the access policy evaluation step, because this is not a business application, there's no business for this hostname to be included in any access policy, there's not going to be any policy match. And this is the key distinction between this flow and the previous flows that entailed work applications access. The IP that's returned to the device is the real IP address. So then from there on, of course, the device connects directly, completely outside of the Jamf cloud. This approach, the way we designed this all, is that only applications that you intentionally include in your access policies are going to be routed and secured via the Jamf Security Cloud. Everything else will flow normally without any added latency or unnecessary overhead. Okay, so hopefully with a bit of a foundation into how things work, I want us to shift our focus now to another tunneling method, Jamf's network relay service, which builds on Apple's native feature of network relay. So Apple introduced the network relay capability, effectively an implementation of Mask, as a better VPN alternative to enterprise access. That's how they refer to it. They introduced it in iOS 16 and macOS 14, so a couple years ago. It uses the same secure transport protocols that power iCloud Private Relay, making it both fast and privacy-focused by design. We've integrated the Apple's network relay feature into our own ZTNA architecture to give you full control of how Apple devices connect from the moment they're powered on. The service enables you to provision your Apple fleet with these application-specific tunnels encapsulated over HTTP3, delivered via Jamf Pro as early as pre-stage enrollment, and no user action required. Access to these tunnels is gated by device identity, which is verified by managed device attestation. And because of the underlying protocols, the service also delivers resilient connectivity, even across networking changes, captive porters, restricted geographies. And with the feature being part of the operating system, it can coexist with other network extension VPNs, which means that you can experiment with it and adapt it gradually without any disruption to existing VPN setups. So for this part, let's have a similar walkthrough at a high level of how network relay-based access comes together. Starts in the Jamf Security Cloud, where you define your access policies for the applications you want to protect. As part of that setup, you also create an activation profile that generates a configuration profile. And there's two key pieces of information here. There's the network relay payload, which includes all those host names and IPs that you defined against the access policies, and then Acme payload. And then this configuration profile is sent to Jamf Pro, and from there pushed to the scoped devices. As soon as the device receives it, it automatically obtains an Apple-attested Acme certificate issued by Jamf's own Acme CA. I'm going to dive deeper into this particular flow in just over the next slide. But for now, let's stay with the big picture. And every time the device needs to connect to any of the work applications that's bound to any of your access policies, this Acme client certificate will be automatically used to authenticate and to secure that mask tunnel. And once the request reaches the cloud, the flow is identical as if the request came through WireGuard. The access policy engine evaluates in real time whether the request should be approved, and if so, the traffic is then brokered out of the cloud over to the destination application. This type of deployment affords the Mac admins a means to deploy new Mac devices, new Apple mobile devices, not just iOS and iPadOS, also Vision Pros and Apple TVs, bring them online and have them securely connected to any networking service and application they need from the moment they're unboxed with zero user interaction. And the better part is that the zero user interaction is still fully secure because access is tied to the device's hardware attested identity verified by Apple. So we established that a configuration profile is generated in Jamf Security Cloud and then pushed through Pro onto the device. Once on the device, a hardware-bound private public key is generated, and the device will initiate an Acme exchange with our Jamf Acme CA. The Jamf Acme CA will do a first verification, particularly that the Acme payload was generated by a legitimate Jamf Security Cloud instance, and it wouldn't have been fabricated elsewhere. And then it's going to send back to the device an attestation challenge. With that, the device is going to start the actual attestation process with Apple's attestation servers, which will result in an attestation certificate being returned to the device. So this is what attests that the device it hasn't been tampered with, it's a genuine device, it's company managed, all these claims. And then with this attestation certificate, the device is now emitting a client signing request to the Jamf Acme CA, which closes the loop and returns this Acme client certificate that is used by the device to secure any traffic sent through the network relay tunnels. For those of you who want to dig deeper, we recommend you look up Mask and QUIC. These are the two protocols that power the network relay. But yeah, just for a quick sense, right? QUIC is the most modern transport protocol. It's as fast as UDP and as reliable as TCP. It runs over port 443 UDP. And Mask is a tunneling framework that allows to create these very narrow application-specific tunnels defined either by IPs or by domains. You're going to have access to these slides, so I'm not going to get any deeper into this. I think we've had enough of that. And now we're going to see a demo. Sorry, I moved too fast. OK, so the next demo, we're going to show you how a device that is just managed under Jamf Pro management, but with no VPN or ZTNA bits that would allow it otherwise access. We're going to go from that device, allowing that to have instant access to all the work applications that it needs to. So for the first part of the demo, we see that the user on the device is going to try to connect to a number of applications. The first one is a sample test application that we use sometimes. It could not connect. Then it's going to try to connect to an internal application that's reachable via an IPsec tunnel. Cannot connect, doesn't have a route. And then for the last part of the test here, they're going to try to set up the email client. And it's not going to work because the Microsoft application was set up to only allow traffic coming from those egress IPs that we discussed earlier. So it is not trusted traffic the moment you're connecting directly to Microsoft. So the device, right, cannot go anywhere. Now we're going to see on the next part of the demo, we're going to see the administrator going into Radar, which is the Jamf Security Cloud portal. And from there, we already have that configuration profile defined. We're going to simply see the admin push that config profile straight from Jamf Security Cloud. It doesn't even need to go into Pro So this is the profile. We're going to see how all the groups that are available in Pro are shown here. We select the all iPhones group, and we push that config profile to the device just through this single click button. And the next instant, all that ACME exchange that we saw just happened now. So the moment that config payload was dropped, we also see that network relay payload is loaded. All these host names, IPs, those are the ones that are part of the access policies that are defined in this Jamf Security Cloud. And now we're going to see how the user is going to try to connect to all those applications that before were not available. So the first one, going to see the device connecting from Singapore because this was the gateway that was configured on the access policy attached to this application. Next, we're going to see how they're connecting. They landed on the login page of the internal application. And then lastly, here, we're going to see how they can set up their email client. We did not speed up any of the timings here. So we didn't do a live demo, but if we did, this would have been the exact timings. OK, so that was the demo part of our presentation. Right, so the WireGuard, the network relay, we covered a lot here. I'm not going to go through any of these key features again. I wish I could tell you that there's universally one option is better than the other, but the reality is that you're going to have to figure it out for your environment, for your user needs, for your administrator needs, if one is better than the other. I think the good thing here is that we have options. And then for those of you who have access to the ZTNA capability, you could request access to the network relay tunneling method. As I mentioned before, this is available in limited availability as a release candidate. We're going to show this QR code in a few more slides as well. So if you want to take a quick snap now, we're also going to show it in a little while. OK? Going to hand it back to Alex. Closing remarks.
Iulia.
Thank you.
Yes, thank you.
Thank you.
Yes, round of applause for Iulia. She's done the difficult bit there. I've got the easy bit of the summary and bits. So yes, thank you very much, Iulia. So to quickly summarize, in light of time, key takeaways of everything we've covered this afternoon. Firstly, why not traditional VPN? Remember those key challenges. Complex to manage. There's hardware to maintain. That means complex configurations. It means certificates to manage, and so on. And it's substandard to use, which means slow connection speeds that don't scale to mobile devices, and thoroughly unintuitive. Thirdly, it's insecure by design. It allows lateral movement between applications, regardless of someone's role or permission set. And it's reactive, not proactive. It assumes an enormous level of trust. In contrast, the ZTNA advantage is secure by design. It requires device and/or user verification. It offers continuous risk evaluation and per-application microtunnels, mitigating that risk of lateral movement between apps. It's a seamless experience. It means any application, anywhere, anytime, and hyper-fast connectivity, ensuring the native platform experience that users expect from their mobile devices. And it's simple to manage. Integrated verification with third-party MDM providers, with identity providers. It's cloud-native with no hardware, and it's easily scaled. And in line with this, what can Jamf Connect Zero Trust offer? Multiple different routing options for different needs. WireGuard for your broader device estate, or the Apple-focused Apple-native network relay capability. Management status assessment, making sure that devices are managed according to our requirements and compliant. Risk posture assessment for both user and device. And application and user context, the enforcement of that concept of least privilege, making sure only the correct users can access the right apps for their role. And lastly, the enforcement of all of these concepts in real time, continuously, for all applications across all platforms, wherever users may be. So finally, to wrap things up, let's quickly revisit the key principle of zero trust, the model that's built upon that mindset of never trust, always verify. And we can summarize this with three key pillars. First, always verify. No user or device should ever be inherently trusted, even if they're inside our corporate network or perimeter. Every access attempt must be authenticated and verified. Devices must be secure and compliant, and their access requests must take a secure, trusted route. Second, least privilege. Users should only ever be able to access the apps they need appropriate for their specific role. This prevents that risk of lateral movement between apps, thus reducing your attack surface and helping to contain any potential breach. Which brings me perfectly on to point 3, the concept of assume breach. This is a mindset shift. Rather than hoping that nothing's gone wrong, we proactively log, we proactively monitor, and we proactively inspect, under the assumption that compromise is always a looming possibility. And by doing so, that is how we stay ahead. Together, these pillars found a truly strong foundation for a zero-trust approach, one that supports both security and productivity in this hybrid working environment we deal with today. So, thank you very much for your time this afternoon. We would absolutely love to take any questions. We've got a little bit of time, I think, which is great. Same again with the QR codes. I have been known, by the way, to put phishing QR codes up on screen in presentations, so I promise these aren't those. If you'd like to connect with us more, please do. They go straight to our LinkedIn. We'd love to chat with you more, field any of your questions. We're going to do some Q&A now as well. And just a final thing, we do have a live lounge at 20 to 5, 4:40? 4:40 this afternoon. We would love to see you there if you can come and join us, and we'll chew the cud on this. Thank you.
Thanks so much, Alex and Iulia.